Hey, welcome to another video. In this video I'll be going through an A-level exam paper. This is an exam paper from the sample assessment materials for Edexcel. I've already been through paper 1, which is Pure Mathematics 1. This is paper 2, Pure Mathematics 2, again for the new specification. As always, I recommend you have a go at this paper before you watch any of this video. If you have a problem with any of the questions, you can just skip to that question and check out my explanation, my working out. I will link the paper and the mark scheme in the description for you to download if you haven't got those already. So about the exam itself, it's a 2-hour exam. You're allowed a calculator and a formula sheet. And I think that's about everything I needed to say. So let's get straight into the questions. Question 1 gives us a function, f of x equals 2x cubed minus 5x squared plus ax plus a. And it says, given that x plus 2 is a factor of f of x, find the value of the constant a. Okay, so what does this mean, x plus 2 is a factor? Well, let's just think about a quadratic, just because it's easier to think about a quadratic than a cubic. So just take a regular quadratic such as x squared plus 5x plus 6, and we could set that equal to 0. If it didn't equal 0, then you just rearrange it so it did equal 0. We can factorize this into 2 brackets. So you know how to do that already. And this is going to be x plus 2, x plus 3. And you would say that after you factorize it, x plus 2 is a factor and x plus 3 is a factor. And what you can say after that is that either x equals minus 2 or x equals minus 3. Okay, so they are the factors, x plus 2 and x plus 3, and that means that to make this equal to 0, x would be minus 2 or minus 3. So when this is saying x plus 2 is a factor, we know that minus 2, if we substitute minus 2 into this function, it will equal 0. So we can use that idea to find a. So we can say that f minus 2 equals 0 as x plus 2 is a factor. Okay, and now we can substitute that into this function. So 2x minus 2 cubed minus 5 minus 2 squared plus minus 2a, and then plus a equals 0. And now we just need to go ahead and solve this to find a. So minus 2 cubed is minus 8 times 2, that's minus 16. Minus 2 squared is 4 times minus 5, that's minus 20. Minus 2a plus a, that's minus a, and all of that equals 0. Alright, so we could just plus a to the side, minus 16 minus 20, that's minus 36. So altogether a is going to equal minus 36. And we're done for 3 marks for question 1. Now if you didn't spot that idea that if x plus 2 is a factor, then minus 2 will make that equal to 0, you might try polynomial division. So you might have set up something like this, where there's the factors here, x plus 2, and you try to figure out what the quotient here is. So you'd say, well, if x times something is 2x cubed, what is that something? X times 2x squared is 2x cubed, and then 2 times 2x squared, that's 4x squared, and you can go through that procedure to find a as well. It's a bit more complicated that way, but you can still do it that way if you want to. Question 2 says, some A-level students were given the following question: solve for theta between minus 90 and 90 degrees. The equation cosine theta equals 2 sine theta. The attempts of 2 of the students are shown below. So student A says cosine theta equals 2 sine theta, then tan theta equals 2, therefore theta equals 63.4. Student B says cosine theta equals 2 sine theta, cosine squared theta equals 4 sine squared theta. So they've squared both sides. Cosine squared they've turned into 1 minus sine squared equals 4 sine theta. Then they've done some rearranging to get sine theta equal to plus or minus 1 over square root 5. and then they've got two solutions for theta. And part A says identify an error made by student A. So we can see they've divided by sine theta on the left hand side, and then they've set cosine theta divided by sine theta equal to tan theta. So this is incorrect. It's actually sine theta divided by cosine theta equals tan theta. So that's the error they've made. So we just need to write that down for part A. Student A, cosine theta divided by sine theta does not equal tan theta. Okay, and the question goes on. Student B gives theta equal to minus 26.6 as one of the answers to cosine theta equals 2 sine theta. And B part 1 says explain why this answer is incorrect. So we can have a careful look at this, and there's actually nothing wrong with any of the working out here, but they have squared this equation and they've forgot to do something at the end. So what we need to do is to check this minus 26.6 in this equation. So substitute it in. So B part 1, and let's say cosine minus 26.6, you can put that into a calculator. So the cosine of minus 26.6 equals 0.89. Okay, this is in degrees. And then we could do 2 sine minus 26.6. And we get minus 0.8955. So you can see those two things are not equal. So we can say that in our answer, cosine of minus 26.6 is not equal to 2 sine minus 26.6. Therefore, this solution is not possible. And part 2 says explain how this incorrect answer arose. So as I said before, they've squared this equation. Now, an important part of solving equations when you're using algebra is that the steps you take are reversible. So if you do something to solve it, you need to be able to go backwards and end up with the same equation that you started with. However, if you square an equation, that changes things, because I've squared this 4, for example. If I try to go backwards by square rooting that equation, a possible solution would be cosine theta equals minus 2 sine theta. So if I squared both sides of that, I would still end up with cosine squared theta equals 4 sine theta. So we've changed the original equation by squaring both sides. We now have two different equations that we're solving. So what you need to do, if you square both sides of this equation, you need to, when you get your answers, you need to check them in the original to make sure that they are valid solutions. So if you did that, if student B had done that at the end, they would have realized minus 26.6 is not a valid solution to this equation, and the only one is plus 26.6. So they haven't checked their final answers, and also the squaring wasn't really necessary. This is the correct approach as long as they've done the dividing by cosine instead of dividing by sine. So you can say something like, once you square both sides, you're adding extra solutions which may be incorrect. Make sure to check final solutions. Question 3 says, given that y equals x bracket 2x plus 1 to the power 4, show that dy and dx equals 2x plus 1 to the power n multiplied by ax plus b, where n, a, and b are constants to be found. So here we need to take the derivative of this equation and find the constants in this equation. So let's start off by finding dy and dx. For this, we're going to need the product rule. So the product rule says if we have y equal to fg, the derivative of that will be the derivative of f multiplied by g plus f multiplied by the derivative of g. So for this one, we need the derivative of x, which is just 1, and then g. So g is 2x plus 1 to the power 4. So I can just write that, because it's only multiplied by 1, so it's just the same thing. Then we add on f, which is x, multiplied by the derivative of g. So for this we need to use the chain rule. So we deal with the power and then we deal with what's inside the brackets. So first we have, we bring that power down and subtract 1. So we've got 4 2x plus 1 to the power 3. Then we multiply that by the derivative of what's inside the brackets, which is just 2. So now we've done all the hard work. We just need to simplify this into the form that they would like us to have it in. So here, let's just leave this first part as it is for now and deal with this. So here we've got 4 times 2 is 8 times x, so we'll have 8x multiplied by 2x plus 1 cubed. And then hopefully you can see the next step, we need to factorize something. We can factorize a 2x plus 1 cubed out of both terms. And what's left is a 2x plus 1 and a plus 8x. And now we have some like terms inside these brackets. We're not multiplying, we're just adding them. So we can add this 2x to this 8x. And we'll have 2x plus 1 cubed multiplied by 10x plus 1. And now this looks like the form they want us to have it in. So 2x plus 1, and n is 3, a is 10, and b equals 1. And that was question 3 for 4 marks. So there you needed the product rule and the chain rule as well. Question 4 says, given f of x equals e to the x, where x is any real number, and g of x equals 3 log x, where x is greater than 0 and x equals any real number, find an expression for g of f, simplifying your answer. So this is a composite function, and for part A we can write this as g f of x equals, we need to put this function for f inside the function for g. So g is 3 natural log, and when we get that x we need to put in e to the x. And all we need to do here is to evaluate this expression. Well, what's the natural log of e to the x? Well, that's like saying what's the log base 10 of 10 to the x. So the log is saying what power do I give to 10 to make it equal to 10 to the power x? Well, it's just x. So the natural log, that's the log of base e. So if we're asking what's the log base e of e to the x, well, that's just going to be x. So this is 3x. Then part B says show that there is only one real value of x for which g of f equals f of g. So we've got g of f. Let's work out f of g now. So we need to substitute g into f. So we've got e to the power of 3 log x. Now another way of writing 3 natural log x is the natural log of x raised to the third power. So that's a log rule that hopefully you have used before. So we could write this as e to the power of natural log of x cubed. Now this is a similar situation to when we have the log base e of e to the x. What happens is that these effectively cancel each other out and we're just left with x cubed here. So e to the power of natural log x cubed is just x cubed. And so we have f of g equal to x cubed and g of f equal to 3x. And we need the only value where g of f equals f of g. So we need to make these two things equal each other. So we can say that x cubed equals 3x. So one possible solution here is that x equals 0. That would satisfy that equation, but the log function is not defined for x equals 0. So we need to find another solution. You could divide by x here on both sides. Another way is to subtract 3x from the left hand side, so x cubed minus 3x equals 0. And then factorize, so x multiplied by x squared minus 3 equals 0. and this equation gives you all three possible solutions. So if you did it the other way, so if you divide it by x, you get x squared equal to 3. You'd only get two of the solutions from that. So anyway, so here we've got x equals 0 or x equals plus or minus the square root of 3. The only possibility here is that x equals root 3. So we could say that the natural log x is not defined, so that root 3, positive root 3, is the only real solution. And that part A was 2 marks and part B was 3 marks. Question 5 says the mass m grams of a radioactive substance t years after first being observed is modeled by the equation m equals 25 times e to the power minus 0.05 t. According to the model, part A says find the mass of the radioactive substance 6 months after it was first observed. So for part A, we have the equation m equal to 25e minus 0.05 t, and 6 months in years, well, that will be when t equals a half, 0.5. So we just need to substitute that into the equation. So m will equal 25 multiplied by e to the minus 0.05 times 0.5. Plug that into a calculator. So 25 times e should be above the natural log button there, to the power of minus 0.05 times 0.5, and you should get an answer of 24.38 approximately. So 24.38, and that's in grams to 2 decimal places. Part B says show that the derivative of m with respect to t equals km, where k is a constant to be found. So we need to take the derivative of this expression, and we need to use the exponential rule. So the exponential rule says that the derivative of e to the power of u, where u is some expression of x, equals e to the power u multiplied by the derivative of u. So in other words, taking the derivative of e to the x has no effect on e, but it's kind of like the chain rule where you take the derivative of u. So this is going to be the derivative of the power of e, so that's just minus 0.05, so that's brought down, and then we multiply that by 25e to the minus 0.05 t. So again, that part of the expression is not affected due to the exponential rule. And so the question is asking dm over dt equals km. Well, here we have m, this is m, equal to 25e to the minus 0.5 t, and therefore k, that constant in front of m, is minus 0.05. So we can say, therefore, k equals minus 0.05 for 2 marks. So part A, 2 marks, part B, 2 marks. Question 6 says, complete the table below. The first one has been done for you. For each statement, you must state if it is always true, sometimes true, or never true, giving a reason in each case. So the first statement says the quadratic equation ax squared plus bx plus c equals 0 has 2 real roots. So this is sometimes true, and the reason is it only has 2 real roots when the determinant b squared minus 4ac is greater than 0. When b squared minus 4ac is equal to 0, there's 1 real root, and when it's less than 0, it has 0 real roots. So we're going to have to choose whether it's always, sometimes, or never true, and then give a reason. So the first statement is when a real value of x is substituted into x squared minus 6x plus 10, the result is positive. So is this always, sometimes, or never true? Well, let's have a look at this quadratic equation. So we've got x squared minus 6x plus 10. You could try to factorize it, but it doesn't quite work. There aren't any factors of 10 that make minus 6. And so because we can't factorize it into 2 brackets, we can use completing the square. So we take half of this coefficient of x and write that inside the brackets here and square those, so x minus 3 all squared, that will make x squared minus 6x plus 9. So to make this equivalent, we need to add 1 on the end. So if we expand that out and simplify, we'll get x squared minus 6x plus 10. And so now we can see, it's a bit easier to see if this will be positive or negative given any value of x. Because these brackets are all squared, anything squared is a positive number. So no matter what number we put into this, whether we get a negative or a positive inside these brackets, once we square it, it'll be a positive number. So that tells us that this quadratic equation for any real value of x must always have a positive value. So this is going to be always true. We can just give a bit of more of an explanation here. So we can say as x minus 3 all squared is always greater or equal to 0, greater than or equal to 0, then x minus 3 squared plus 1 must always be greater than or equal to 1. So always true, always positive. The second statement is if ax is greater than b, then x is always greater than b over a. For this one, I just tried different values for each one. I didn't try to prove it algebraically, so we could try some values for a and b. So firstly, I tried a negative value for a and a negative for positive for b, sorry. So substitute those values into this first statement. So we've got minus 1x is greater than 1. So for this to be true, the x needs to be a negative number greater than or equal to minus 2. So x needs to be greater than or equal to minus 2. So we could try minus 2. So let's say x equals minus 2. That means that minus 2 would be greater than b is 1. Using this second statement now, b is 1, a is minus 1. And so minus 2 is clearly not greater than 1 over minus 1. That would just be minus 1. So minus 2 is not greater than minus 1, so this doesn't work. So for these values of a and b, this statement is not true. So we've already found one example that is not true. But if we try some positive values of a and b, such as a equals 1 and b equals 1, then 1x, x is greater than 1, therefore x is greater than or equal to 2, basically. And then so let's say x is 2, that will be greater than 1 over 1, which does work. So those two statements do work if a is 1 and b is 1. So that one does work. And to sum this up, you could try a few more examples and you find that it is only true when a is greater than 0. So for a less than 0, these statements don't work. So clearly this is sometimes true. And the last statement, the difference between consecutive square numbers is odd. So consecutive square numbers, if we think of the square numbers 1, 4, 9, 16, 25, etc. The consecutive square numbers are the ones next to each other. So 4 and 9, 16 and 25, they're consecutive square numbers. And so if we're talking about the difference between consecutive square numbers, well, let's have a look. So the difference between 1 and 4 is 3, 4 and 9 is 5, 9 and 16 is 7, 16 and 25 is 9. So they're all odd numbers, so it's looking good so far. Can we prove this algebraically? Yes, we can. So if we think of any square number, we can take a number and square it. That would give us a square number. The next square number would be that number a plus 1 and then square that. So for example, a might be 3, square that would get 9, a plus 1 is 4, square that would get 16. So these are the two consecutive square numbers. We can find the difference between those by subtracting them. So a plus 1 squared minus a squared. And we can simplify this to find the difference algebraically. So expand those brackets out, we get a squared plus 2a plus 1 minus a squared. And you can see these a squareds cancel each other out. So a squared minus a squared, they disappear. And we're left with 2a plus 1. And so anything multiplied by 2 plus 1, that will be an odd number. So we've shown that with an example, and we've also proved it algebraically, and that will always be true. And you could write an explanation as well for that, something such as any number multiplied by 2 plus 1 is odd. So therefore it's always true. And that was question 6 for 6 marks. Question 7 part A says, use the binomial expansion in ascending powers of x to show that the square root of 4 minus x equals 2 minus a quarter x plus kx squared plus the rest of the terms, where k is a rational constant to be found. Okay, so let's start on that. So for part A we need the binomial expansion, and for 1 plus x we have this formula. So for 1 plus x to the power of n, we have 1 plus nx, where x represents whatever is in this space here, not just the x by itself, plus n times n minus 1 all over 2 factorial multiplied by x squared, and that keeps going. We only need it for the first 3 terms, so that's all I'm going to write. There is also a generalized formula which you could also use in this question if you're familiar with it. It's a plus b to the power of n equals n count 0, x to the power n, y to the power 0, plus n count 1, x to the power n minus 1, y to the power 1, plus n count 2, x to the power n minus 2, y squared, etc. So we could use that because we don't have it in the form 1 plus x, but we can factorize so that we can write it in this form, which is the way I'm going to do it, but you'd be fine with that formula as well. So let's firstly work with this expression a little bit. So we've got the square root of 4 minus x. So this can be written as the square root of 4 times 1 minus a quarter x. So I've just factorized a 4 out of both terms, which could be written as the square root of 4 times the square root of 1 minus a quarter x. So you can see that then I can write it in this form, 1 plus x to the n. So then this is going to be 2 multiplied by 1 minus a quarter x to the power of a half. Okay, so what I want to do is just evaluate this part of the expression, 1 minus a quarter x to the power half, and I can just ignore this 2 until the very end where I can add it back in to the expression. So starting with this part, 1 minus a quarter x to the power of a half, I can use my binomial expansion formula to get these terms. So starting with 1 plus n, which is a half, multiplied by x, which is this whole term here, this minus a quarter x, plus n, which is a half, multiplied by n, which is a half minus 1, divided by 2 factorial times x squared, again the whole term, minus a quarter x all squared. And that's as far as I need to go, again, because they've just given us the first 3 terms and we're looking for k. So we only need to evaluate the first 3 terms of this expansion. So now we need to simplify this. So 1 plus a half times minus a quarter, that's minus 1/8. Didn't really need that plus there, but anyway. X and plus a half minus 1, that's minus a half, times a half, that's minus a quarter. This minus a quarter x squared, that will be 1/16, positive 1/16 x squared, because obviously that negative becomes a positive when you square it, and then 2 factorial is just 2, and we still need to simplify that last term a little bit more. So this is 1 minus 1/8 x a quarter times a 16th, negative a quarter times a positive 16th, that's minus 1 on 64, x squared all over 2. And I'll leave it as that, and you'll see why in a minute. I don't really need to simplify anymore. So that was for 1 minus a quarter x to the power of a half, or a square root of that. And remember, we ignored that 2, but now we can add it back in. So we can say this evaluates to the square root of 4 minus x evaluates to 2 times 1 minus an eighth x minus 1 on 64 x squared divided by 2. So I've added that 2 back in to multiply all of the terms by 2. And if I expand that out, 2 times 1 is 2. 2 times an eighth, that's minus a quarter x, and 2 times minus 1 on 64x squared over 2, well, those 2's would cancel each other out. So for the last term, we'll get minus 1 over 64x squared. So they are my first 3 terms of that expansion. And they're asking what k is in this expression. So we can say that k is equal to minus 1 on 64. So that was part A for 4 marks. Part B says the student attempts to substitute x equals 1 into both sides of this equation to find an approximate value for the square root of 3. State, giving a reason, if the expansion is valid for this value of x. Well, I can't see anything wrong with that. So if we substituted 1 into that, we'd get the square root of 3. And then on the other side, if we substituted 1, we'd get some decimal expansion. So we're not violating any rules of mathematics doing that. We're not taking the square root of a negative or anything, so there shouldn't be any problem. And in fact, this should work for any value of x less than 5, any integer less than 5, because this would be a positive. As long as that's a positive, then it should work. So we can say it is valid, and the expansion is valid when 4 minus x is greater than 0, or greater than or equal to 0, really. As long as that's not a negative, then it should work. So that was just 1 mark, so not too much work there, and that was question 7 for a total of 5 marks. Question 8 gives us a diagram, and it says figure 1 shows a rectangle ABCD. The point A lies on the y-axis and the points B and D lie on the x-axis as shown in figure 1. Given that the straight line through the points A and B has equation 5y plus 2x equals 10, part A says show that the straight line through the points A and D has equation 2y minus 5x equals 4. So we have an equation for AB, and we need to show that the equation for AD is 2y minus 5x equals 4. So this is a fairly straightforward question. You don't actually need any A-level mathematics for this. You can just use the mathematics that you've learnt in GCSEs. Well, what can we do first? Well, firstly, we can find the gradient of AB just by rearranging this equation. So for part A, we can say that the line AB is 5y plus 2x equals 10, and this can be rearranged to y equals minus 2 over 5x plus 2. Okay, so we know the gradient of AB, of line AB, equals minus 2 over 5. Now, we're told this is a rectangle, so that means these two lines AB and AD are perpendicular, and there is something we know about the gradients of lines that are perpendicular. So we can state firstly that AB is perpendicular to AD. So therefore, the gradient of AD equals the negative reciprocal of AB. So we've got the gradient of AB minus 2 over 5, so therefore the gradient of AD will equal 5 over 2. So we flip it and we change the sign for the negative reciprocal. So also we need a point on that line, so we could find a point for D or A. Finding the point for A will be easier because that lies on the line AB. So we can say that point A lies on the y-axis, i.e. when x equals 0. So therefore 5y plus 2, by the way, I'm taking this equation for AB and I'm substituting x equals 0 into that to find the y coordinate. So 5y plus 2 times 0 equals 10. So therefore 5y equals 10. So therefore y equals 2. So I found point A using the fact that it's on the y-axis, so x equals 0 and y equals 2. So therefore point A equals 0, 2. And we have part of the equation for AD. So line AD looks like this so far. Y equals 5 on 2x plus c. We don't know what c is. We need to find that. So we can substitute the point 0, 2 to find c. So this will be 2 equals 5 over 2 times 0, which will just be 0, plus c. So therefore c equals 2. So therefore the equation for line AD will be y equals 5 over 2x plus 2. Alright, so that answers the question. Show that the straight line, we still need to rearrange it a little bit, so multiply everything by 2, so this is going to be 2y equals 5x plus 4, and then subtract the 5x from the other side, so 2y minus 5x equals 4. So we've shown that the straight line through A and D has equation 2y minus 5x equals 4. Part B says find the area of the rectangle ABCD, so this shaded area in here. A couple ways to do this. I chose to me, what was the simplest way. So I found the height and the base of both of these triangles and added those up. You could also use Pythagoras to find these lengths, but I just chose to do it using the coordinates. So starting off for part B, finding area, I need point D and point B as well. So point D will be when y equals 0 for this equation. So when y equals 0, we get 2 times 0 minus 5x equals 4. So therefore x equals minus 4 on 5 for point D. Point B will occur again when y equals 0, but we need to use the equation of the other line. So when y equals 0, 5 times 0 plus 2x equals 10. So therefore x equals 5. So point B is at 5, 0. Point D is at minus 4 over 5, 0. So therefore that line here, let's just draw them in. And this is at 5. So that length of that line is 5 and 4/5. So I can say length of DB equals 5 and 4/5. Also, so I've got the base of the two triangles. I also need the height. So I can just use the y coordinate at point A. So the height of triangle DAB will equal the y coordinate at A, which was 2. So the height of the two triangles is 2, the base is 5 and 4. So therefore the area of one triangle, of say triangle DAB, will be the base times the height, so 2 times 5 and 4/5 over divided by 2. So just work that out. Well, those 2's just cancel, so we get an area of 5 and 4/5. And the other triangle is going to be the same because it's a rectangle, and if you just split a rectangle in half, the two triangles will have exactly the same area. So therefore the area of rectangle ABCD equals 5 4/5 times 2. So stick that in the calculator and you get 11 3/5. And there's no units in that question, so just leave it as that. And that was question 8 for a total of 7 marks. Question 9 says, given that a is constant and the integral of 1 to 4 of 3 root x plus a dx equals 2a squared, show that there are exactly 2 possible values for a. Okay, so we need to work out this integral. Starting off, we'll firstly evaluate the left-hand side of this equation. So the integral of 3 root x plus a dx. Now here we can just use the power rule. So think of that square root as a half. We add 1 to the power, so that becomes 3 over 2. We divide it by 3 over 2. So this is going to be 3x to the 3 over 2 divided by 3 on 2. And then we just have to write x after the a. So we add an x to that, and then we add the constant on the end. And then simplify this part of the expression. So flip that fraction over. So that'll be 2 on 3 times 3. Well, that just works out to 2x to the power of 3 on 2 plus a x plus c. So we've worked out that integral. Now we need to work out the definite integral from 1 to 4. So what we want is 2x to the power of 3 on 2 plus ax from 1 to 4. So firstly, substitute 4 into that expression. So this is like the square root, so this is the same as the square root of 4 cubed plus 4a. Subtract, and now we substitute 1 into that expression. So if we put 1 in for x there, it would just be 1, so that first term will just be 2 plus a times 1 is just a, and then we need to evaluate this. So the square root of 4 is 2 cubed is 8, and 2 times 8 is 16, so we get 16 plus 4a minus 2 minus a, and this will end up equaling 16 minus 2 is 14, 4a minus a is plus 3a. And remember, we started with this equation, so we know that all of that equals 2a squared, so therefore we can say 14 plus 3a equals 2a squared. And now we can rearrange this in the form of a traditional quadratic equation. So if we bring everything over on the same side as the 2a squared, we'll have 2a squared minus 3a minus 14 equals 0. Now we can go ahead and factorize this. So we need 2 factors of 14 and one of them multiplied by 2 to make minus 3. So the factors of 14, 1 and 14, or 2 and 7. Okay, so if we multiply the 2 by 2, we'll make 4. Minus 7 plus 4, that will be minus 3. So we can use the factors 2 and 7 to factorize this. So therefore 2a and a go in the front of the brackets. And then we've got a plus 2 here to multiply by 2a and a minus 7 here. Okay, so if you expand that out, you'll get 2a squared minus 3a minus 14. And so therefore, we have some values of a. So a could equal 7 on 2, positive 7 on 2, or it could equal minus 2. Okay, so after all of that, we've got 2 solutions for a. So therefore, we just need to state. So therefore, a has 2 possible solutions. And that was question 9 for 5 marks. Question 10 says, in a geometric series, the common ratio is r and the sum to n terms is s sub n. Given s sub infinity equals 8 over 7 multiplied by s sub 6, show that r equals plus or minus 1 over the square root of k, where k is an integer to be found. Okay, so we're talking about a geometric series, and we're going to need 2 formulas for this question. The first one is the sum of the terms in a geometric series, and that looks like this. So we have S sub n standing for the sum of n terms in the series, and that equals A sub 1, meaning the first term in the series, multiplied by 1 minus r to the power n divided by 1 minus r being the ratio of the terms. And then the other formula we'll need is the infinite sum formula. So that looks like this, where we have S sub infinity equal to A over 1 minus r, and that's the sum of the infinite terms in a geometric series. So just to recap, a geometric series is anything where you multiply by the same number. So if we start with 2, multiply by 2 we get 4, multiply by 2 we get 8, multiply by 2 again, and again, and again, etc. So you could use this formula. Say you wanted the sum of the first 4 terms, so adding those all up together, could use that formula and you'd get the answer. And if you wanted the infinite sum of that series, you could use this formula. Unfortunately, you couldn't use it for this one because this only works when r is, the absolute value of r is less than 1. So that would not work for this formula. And I know it will work here because they've told me r is equal to 1 over the square root of k. So clearly that number is going to be, the absolute value will be less than 1. So I can use the infinite sum formula here. And we're going to solve this by substituting those formulas into this equation they've given us to find r, to solve for r. So starting off, we can say that taking the infinite sum formula, a over 1 minus r equals 8 over 7 multiplied by, and then use the sum formula, which is a multiplied by 1 minus r to the n. And in this case, we can replace the n with a 6 because we know this is the sum of the first 6 terms. And that's all over 1 minus r. Okay, and now we have everything plugged in. We just need to solve this algebraically. So the first thing we can do is multiply everything by 1 minus r. So everything on the right hand side is multiplied here. So if we multiply the right hand side by 1 minus r, that'll effectively cancel those out. So we can say that on the next line, a equals 8 over 7 multiplied by a multiplied by 1 minus r to the power 6. So we've got rid of those 1 minus r's. They've cancelled each other out. Next, we could divide by a on the left or the right hand side, so whichever you fancy, and they will cancel each other out. So on the left hand side we'll be left with 1, and on the right we'll have 8 over 7 multiplied by 1 minus r to the 6. So those a's have cancelled each other out. Then we could take this fraction over to the left hand side, so it will flip itself around because we multiply by 7 divided by 8. So this will be 7 over 8 equals 1 minus r to the power 6. And we're almost there. Next, we want a positive r to the power 6. That'll make it easier to work out what r is. So to get that positive r to the power 6, take that over to the other side, bring that 7 over 8 over this side, and you'll have r to the power 6 equal to 1 minus 7 over 8. And then, so 1 minus 7 over 8, that's 1/8. So r to the power 6 equals 1/8. And then we need to take the 6th root of the right hand side. So r will equal the 6th root of 1 over 8. And well, the root of 1 is always 1. So really we could write this as 1 over the 6th root of 8. And then we can simplify this a little bit. So if you think of the 6th root of 8, another way to write that is the square root of the cube root of 8. So the cube root of 8 is 2. So 2 times 2 times 2 is 8. So the cube root of 8 is 2. And this can be written as the square root of 2. So after all of that working out, we get r equal to 1 over the square root of 2, and we also need that plus or minus in there. Because we had an even power, so r could have been a negative or a positive number. If you go back to this step here, if we say that r to the power 6 equals 1 over 8, this could be a negative 1 over square root 2 or a positive 1 over square root 2, and you still end up with a positive 1 over 8. So we need to add that positive and negative signs in the answer. And go back to the question asking, show that r is plus or minus 1 over root k, and we need to write k, so k is equal to 2. And that's for 4 marks. Question 11 gives us a graph, and it says figure 2 shows a sketch of part of the graph y equals f of x, where f of x equals 2 multiplied by the absolute value of 3 minus x plus 5, where x is greater than 0. And part A says state the range of f. So let's do that down here. Now for the range, well, this graph doesn't have any upper limit, so it's going to go off into infinity. What we really need to figure out is this minimum down here. So how can we figure that out? Well, if we look at this equation, f of x equals 2 multiplied by the absolute value of 3 minus x plus 5. Because this is an absolute value, it always must be positive. So this can only ever have a positive value, and take any positive number, add it to 5, you get a bigger number. So what's the minimum of this? Well, it'll be when this part of the equation, this part here, with the absolute value in it, will be 0. So 5 is the minimum. So for the range, remember the range is the y values, the domain is the x values, so for the range of f will be from 5 to infinity. So the way we write that is using inequality symbols, so it can be greater than or equal to 5, and then f of x is less than infinity. Okay, that's for 1 mark. Part B says solve the equation f of x equals half x plus 30. So they're saying that they've given this the value of f of x, this equation up here, and they've set that equal to this expression here, half x plus 30. So that's where we need to start. So we need to write that equation out again. So 2 multiplied by the absolute value of 3 minus x plus 5 equals a half x plus 30. Now we need to go ahead and solve this. So the first thing we can do is subtract 5 from the right hand side. So we've got 2 multiplied by the absolute value equal to a half x plus 25. And then we can divide by 2, and we'll have the absolute value of 3 minus x equal to a quarter x plus 12.5. And so to deal with this absolute value side, the right hand side will either be positive or negative. So for the next line, we can say therefore 3 minus x equals positive quarter x plus 12.5, or 3 minus x equals negative quarter x plus 12.5. So that's dealing with that idea that x could be any number in here, but you're only taking the positive numbers. So by making that right hand side either positive or negative, you're dealing with both outcomes, and you get all the possible values for x. So now we need to keep simplifying. So therefore minus x equals a quarter x plus, and now we need to subtract that 3. So we'll get 9.5 on the right hand side. And then let's keep going with this one. So subtract a quarter x from the left hand side, so we'll get 5 quarters x equal to 9.5. And then multiply by 4, divide by 5 to get x by itself. So 9.5 times 4 divided by 5 equals 7.6, 38 over 5. So x equals negative 38 over 5. The other scenario, let's deal with that one now. So negative x equals negative a quarter x, negative 12.5, subtract 3. And so let's add that quarter to the other side. So -1 plus a quarter, that'll be -3/4 x equal to minus 15.5 on the right hand side now. And now we need to multiply that one by 4, divide by 3, and we get 62/3. So x equals positive 62/3 because we had a negative on the right and left hand side. And now we need to go back to the question again, and it says solve the equation f of x equal to this, but remember that x had to be greater than 0 in this for f of x. So x is greater than 0 for f of x. You'll notice that only one of these answers is greater than 0. So we can say as x is greater than or equal to 0, x equals 62/3 for part B. The next part of the question says, given that the equation f of x equals k, where k is a constant, has two distinct roots, state the set of possible values for k. Alright, so a little bit of interpretation needed here. They've told us that k is a constant, so if f of x equals k, that's like saying y equals 2 or y equals 10. So because k is a constant, what do those graphs look like? Well, if you're graphing y equals 2, that's a horizontal line at y equals 2. So every point on that line equals 2, y equals 10, horizontal line. So we know that this graph, the line for this f of x, where k is a constant, that must be a horizontal line. And we also are told that it has two distinct roots. What does that mean? Well, it means that it crosses this graph twice. So it has two solutions where it intersects with f of x. So where could that happen? Well, it could happen down here or up here because it's a horizontal line. It needs to cut this, this graph at two places, and it could happen all the way up to here. It couldn't happen here, it would only cut once. It couldn't happen up here, it could only cut once. So we have a range of values that this could fit inside. It also couldn't be down here because it would have no solutions then. It wouldn't intersect the graph at all. So we know the minimum was 5. We worked that out in part A. We just need where the graph cuts the y-axis. So we need this value here, and we can find that by setting x equal to 0. So for part C, f of x cuts y-axis when x equals 0. So therefore f of 0 equals 2 absolute value of 3 minus 0 plus 5. And that's 2 multiplied by 3. 3 minus 0 is 3. So 2 times 3 is 6 plus 5 equals 11. So that value up here, where the graph cuts the y-axis, is 11. So that's the range of values that k could have. Again, it couldn't be down here, it couldn't be up here, so it could only be between 5 and 11. So let's just give a bit of an explanation. So as k is a constant, y equals k is a horizontal line at k. Distinct roots occur where y equals k intersects y equals f of x. So therefore, k is between 5 and 11. Now it could equal 11 because there are 2 points at 11, but it can't equal 5. It can only be greater than 5. If it did equal 5, it would only cut the graph once at y equals 5. So k is greater than 5 and less than or equal to 11 for part C. And that was question 11 for 6 marks. Question 12, part A, says solve for x between minus 180 degrees and 180 degrees the equation 3 sine squared x plus sine x plus 8 equals 9 cos x squared, giving your answers to 2 decimal places. So here we have a sine x squared, a sine x, and a cosine x squared. and we need to somehow find a way to solve this. You could possibly somehow think of dividing by cosine, maybe changing these to the tangent function. But I think the easiest way is to find a way to change this cosine x squared into a sine x squared. And we can do that using the Pythagorean theorem for trigonometric functions, which says that cosine x squared plus sine x squared equals 1. And following from that, cosine x squared equals 1 minus sine x squared. So we can substitute this 1 minus sine x squared into this equation where the cosine x squared is, and then we'll have them all in sine x form, and then we can see where we go from there. So for part A, that's what my first step is going to be. So this equation will now look like sine x squared plus sine x plus 8 equals 9, 1 minus sine x squared. And if I expand those brackets out, I get 3 sine squared x plus sine x plus 8 equals 9 minus 9 sine x squared. And then keep simplifying, so add that 9 sine x squared over to the left hand side. So therefore 12 sine x squared plus sine x plus, and also I can subtract that 8 from the left hand side, so this is going to become a minus 1, and all of that equals 0. Right, now we have what looks like a quadratic equation, and we know how to factorize quadratic equations and then solve them. So here I have a minus 1, and I need some factors of minus 1 to multiply by some factors of 12 to make plus 1. So if I think of some factors of 12 that might make plus 1, well, that would be 3 and 4. And if I have, say, a minus 3 and a plus 4, then I'll be able to make plus 1. So that means I need to multiply the 3, the coefficient of sine squared x, by a minus 1 to make plus 1. So therefore I can factorize this into 2 brackets, and I'll have a 4 sine x here and a 3 sine x here to make 12 sine x squared. And for this 3 sine x, I need to multiply that by minus 1 and then a plus 1 for the 4 sine x. And if I expand that out again, I'll get 12 sine x squared plus sine x minus 1 equals 0. So now I've factorized it, I can solve for x. So this means that either 4 sine x minus 1 equals 0, or 3 sine x plus 1 equals 0. And then simplifying this, so therefore sine x equals 1 over 4, or sine x equals minus 1 over 3, and therefore x equals the inverse sine of a quarter. So writing this all out, or x equals the inverse sine of minus a third. Now we need to firstly do some interpretations. So what does this mean if sine x equals a quarter? Well, you need to think of your unit circle, and if sine x equals a quarter, the sine function is like the y-axis on this unit circle. So let's say a quarter is here, and the values of sine x are on this circle, so it could either be on this side, going across from a quarter, or it could be on this side. So we're actually going to get 2 values for this. So for the first value, we'll get this angle in here. That's what that x stands for. And then we need to subtract that from 180 to get the second value, which will be this angle here. And same for minus a third. So if we say minus a third is down here somewhere, we go across to the unit circle, and we're looking at this angle in here, but we also have a value over here, and we need to subtract that from minus 180 to get the other value. So we're going to end up with 4 answers for this problem, and we need to work out the inverse sine of a quarter. So get your calculator out, find inverse sine of a quarter, and we get 14.48. And then we need to subtract that from 180 to get the second value, minus the answer, and we get 165.52 as well. Or we need to work out the ones for the inverse sine of minus a third. Put that into your calculator, and you get minus 19.47. And then we need to do minus 180, subtract that answer as well, and we get minus 160.53. So 4 answers there, and that was part A for 6 marks. Part B says, hence find the smallest possible solution of the equation 3 sine squared 2 theta minus 30 plus sine 2 theta minus 30 plus 8 equals 9 cosine squared 2 theta minus 30, giving your answers to 2 decimal places. Sorry, giving your answer to 2 decimal places. Firstly, we need to recognize that this equation is exactly the same as this one. They've just replaced x with 2 theta minus 30. So we calculated what x was here. We got 4 answers for x for the solution for this equation. So we can make those answers equivalent to 2 theta minus 30, this part of the equation. So for part B, we're saying that x equals 2 theta minus 30 from part A. And then we need to substitute these values in for x to find the smallest possible value of theta. So if you look at these, what we're going to have to do to solve this equation is firstly add 30 degrees to one of these values. And remember, it says the smallest positive solution of the equation. So if I add 30 to 14, I'll get about 44. 165 plus 30 would be about 195. If I add 30 to 19 minus 19, I'll get approximately plus 10, and for minus 160 I'll get about minus 130. So if we're looking for the smallest positive value of theta, minus 19.47 is going to give me the smallest positive number here. So we can say that 2 theta minus 30 equals minus 19.47. Add 30 to that, so 2 theta equals 10.53, and then divide by 2, so theta equals 10.53 divided by 2, and we'll get 5.26 degrees. And if you want to be safe, you can substitute that back into that equation to make sure the left hand side equals the right hand side, but that's going to give you the smallest positive value for theta, and that was part B for 2 marks, and question 12 was a total of 8 marks. Question 13 part A says express 10 cosine theta minus 3 sine theta in the form r cosine theta plus alpha, where r is greater than 0 and alpha is between 0 and 90 degrees. Give the exact value of r and give the value of alpha in degrees to 2 decimal places. Okay, so to work this out, we need the sum formula for the cosine function. So we'll start by writing that down. So for 13 part A, we're going to need the sum formula, which looks like this. So cosine of theta plus alpha equals the cosine of theta multiplied by the cosine of alpha minus sine theta sine alpha. So hopefully you have a formula sheet for trigonometric functions available. You're not expected to memorize all of these, and you can have a formula sheet in the exam, so hopefully you have some of these written down and you'll have these, hopefully these sum and difference formulas written down. So there's the one we're using there. And so because we know that the cosine of theta plus alpha equals all of this, we can say that therefore the cosine of alpha equals 10, and the sine of alpha equals 3. And I'll just write the expression we were starting with over here so you can see that clearly. It was minus. So here we're saying that the 10 is equivalent to cosine alpha and the 3 is equivalent to sine alpha. Now we can say therefore tan alpha equals sine alpha over cosine alpha. So that's 3 over 10. And then to find r, we take the square root of the squares of both of those numbers. So that's the square root of 109. So that's the general process of questions like this, where you're asked to take, some number cosine x plus or minus another number, so sine x. You can use this process. And also, if you're wondering why I can say that tan alpha equals 3 over 10, or r equals the square root of 3 squared plus 10 squared, it's not hard to show why this process works. It's just a bit longer, but I might do another video on that if anyone's interested, or hopefully you're familiar with that method already. But in this case, we can say r is equal to the square root of 109. And because tan alpha equals 3 over 10, we can say alpha equals the inverse of tan of 3 over 10. And if you put that into a calculator, you get 16.7 degrees rounded off. So therefore we can say that 10 cosine theta minus 3 sine theta equals the square root of 109. Cosine theta plus 16.7, and that was for 3 marks. Oh, I've just noticed this says to 2 decimal places, and I believe that rounded off to 16.70. It was 16.699 something, so 16.70 to 2 decimal places for alpha. Okay, continuing the question. So part B says the height above the ground, h meters, of a passenger on a Ferris wheel t minutes after the wheel starts turning is modeled by the equation h equals a minus 10 cosine 80t plus 3 sine 80t, where a is a constant. Figure 3 shows the graph of h against t for 2 complete cycles of the wheel. Given that the initial height of the passenger above the ground is 1 meter, B, part 1 says find a complete equation for the model, and part 2 says hence find the maximum height of the passenger above the ground. Okay, so we have a passenger on this wheel going around, and it's modeled by this graph, and we've got this equation, and we need a complete equation given that the initial height is 1 meter, so that means at t equals 0, h is equal to 1. So that will allow us to find a by substituting h equal to 1 and t equal to 0 into that equation. So we'll start off with that. So for part B, part 1, we've got h equal to a minus 10 cosine 80t plus 3 sine 80t. Should have brackets around those. And for the initial position, we've got at t equals 0, h equals 1 meter. So therefore, 1 equals a minus 10 cosine. Now if we substitute 0 in for t, that'll be the cosine of 0 plus 3 sine of 0 as well. And the cosine of 0 is just 1. The sine of 0 is 0, so that will cancel that part out. And we'll be left with 1 equal to a minus 10. So therefore a equals 11. So the complete equation, we'll have 11 substituted in for a, so that will look like this: h equal to 11 minus 10 cosine ATT plus 3 sine ATT. Or we can write that another way. So you notice that this part of the expression looks very similar to the one we had in part A, 10 cosine theta minus 3 sine theta, where theta is replaced by ATT. And we found that that evaluated to the square root of 109 cosine theta plus 16.70. Now you might say that there's a positive here in this one and a negative in this one, but it doesn't really make much difference. We could rewrite this one as h equal to a minus, now if we factorize a negative out there, we'll get 10 cosine ATT minus 3 sine ATT. And you see that there we've got this expression now in the brackets here, and we haven't really changed anything. We've just taken out a negative from those two terms, but it still looks pretty much the same. So what we can do is we can replace all of this here with the expression we found in part A, and also we need that 11 at the front. So we've got h equal to 11 minus, and now we can substitute this expression in. So we've got the square root of 109 cosine, and theta is replaced by ATT. So cosine of ATT plus 16.70. And so we have two different ways of writing that complete equation. And now if we go back to part B, we need part 2 now, hence find the maximum height of the passenger above the ground. So if we look at the graph, that'll be up here. And if you think about the trigonometric functions, sine theta and cosine theta, their values lie between -1 and 1. So they're the maximum values, if you like, of those functions. And so that's going to help us find the maximum height. So looking at the cosine function, its maximum value is 1. And if we go down to this equation, how are we going to find the maximum h, the maximum height? Well, that will be when this part of the expression, this cosine part, that evaluates to -1. That will give us the largest h value, because this negative will turn into a positive, and we're adding the highest number we possibly can. If this evaluated to a number larger than -1, say -1/2, then the number we're adding on would be smaller, so we'd get a smaller h. So what we want is when the cosine part of this function equals -1, then we'll get the largest, the maximum height. So for part B, part 2, we can say maximum height occurs when the cosine of ADT plus 16.70 equals -1. So therefore, the height equals 11 plus the square root of 109. And we can put that into a calculator to get a value. So 11 plus the square root of 109 gives us, we could change that to a decimal, 21.44 meters, I believe. 21.44 meters. I think you could probably leave it as that, but just to be safe, you can give the decimal answer as well. Part C says find the time taken to the nearest second for the passenger to reach the maximum height on the second cycle. Right, so we've got the first one here. That was the first cycle. Here's the second cycle. Now, when does the cosine function equal -1? If you think about the unit circle, we have the cosine equal to -1 at 180 degrees. So over here, at 0 it equals 1, at 180 degrees it equals -1. And then if we go around again, it will get back to -1, and that will be 540 degrees. So we've gone a full 360 again. 360 plus 180 is 540 degrees. So the second cycle, the maximum height of the second cycle, when the cosine function equals -1 again, that will be 540 degrees. So how does that fit with this part C? So find the time taken to the nearest second for the passenger to reach the maximum height in the second cycle. Well, if we look at this part, again, remember we said that the cosine of 80t plus 16.70 had to equal -1. Well, effectively there we were saying that 80t plus 16.70 equals 180 degrees. So for the second cycle, we're saying that the cosine of 80t plus 16.70 equals -1 again. And this happens when 80t plus 16.70 equals 540 degrees. So now we can solve this for t. So subtract 16.7 from 540, divide by 80, and we'll get a value for t. Let's just do that on a calculator. 540 subtract 16.7 equals divided by 80, and we get 6.54 minutes, 6.54, and if we want to write that as minutes and seconds, we can multiply that decimal by 60, 125 times 60, and we get about 32 seconds. So this will be 6 minutes, 32 seconds. Alright, so 6 minutes 32 seconds to reach the peak on the second cycle. And part D says it is decided that to increase profits, the speed of the wheel is to be increased. How would you adapt the equation of the model to reflect this increase in speed? Okay, so for part D, the wheel is increasing. Let's just look at the graph again quickly. Now, if the speed of the wheel is increasing, what's going to happen to this graph? What's going to happen to the peaks and the troughs? Well, if the wheel is spinning faster, that means people are getting to the top faster. So the time taken to reach the peak height will be less. It'll get down quicker, and it'll get up to the top quicker and down quicker, and they'll be finished. So what's happened to the period of this graph? So from each minimum or each maximum, that's the period. What's happened to that? It's shrunk, it's got smaller. Now if you think of a cosine or a sine function, the coefficient of theta, say you've got a number here like cosine of 2 theta, that value is the one that affects the period. And the bigger that gets, the smaller the period gets. So if you graph, say, cosine of 3 theta and the cosine of theta, you'll notice the cosine of 3 theta has much closer together curves. The period is much smaller than cosine theta. So that coefficient affects the period. And if we look at this function here, 80 is the coefficient of t. So we're going to have to increase that number to shrink this period down. So if we could increase it, they haven't told us how much faster, or they haven't quantified what the increase in speed is. So we don't really need to give an exact number. We can just say it would be 90 or 100 or something. So we just need to explain ourselves for part D. We can say something like the speed is increased, therefore max height is reached faster, therefore period is reduced. This is affected by the coefficient of t. So we can increase coefficient from say 80 to 90. So the new equation will look something like e.g. h equals 11 minus 10 cosine 90t plus 30 sine 90t. Okay, so that was question 13 for a total of 9 marks. Let's just look at the parts. So Part A was 3 marks, Part B was 2 marks, Part C was 3 marks, and Part D was 1 mark. Question 14 says a company decides to manufacture a soft drinks can with a capacity of 500 milliliters. The company models the can in the shape of a right circular cylinder with radius r centimeters and height h centimeters. In the model, they assume that the can is made from a metal of negligible thickness, just meaning you don't have to worry about how thick the metal is. And part A says prove that the total surface area s centimeters squared of the can is given by s equals 2 pi r squared plus 1000 over r. Okay, so how can we go ahead and prove this? Well, we know the formula for the surface area of a cylinder and the formula for the volume of a cylinder. We're going to have to combine those together to get this formula for the total surface area of this particular can. Okay, so we're told, the only thing we're told is that it has a volume of 500 milliliters. So we can start with that. So for part A, we can write down the formula for the volume of a cylinder, and that is the area of the circle on top. Let's have a go at drawing a cylinder over here. Okay, well, you get the idea there. So the volume is the area of the circle on top multiplied by the height. Okay, and this is the radius in here. So that's multiplied by height. And we're told the volume is 500 milliliters. So therefore we can say that pi r squared multiplied by h equals 500. And now we want to take the surface area formula for the cylinder. So surface area is 2 pi r, so the circumference of that circle on top, multiplied by the height. So that will give us actually the area of this rectangular shape around the cylinder. And then we add the area of the two circles on the top and bottom, so 2 pi r squared. Alright, so what we want now is to rearrange this volume formula so that h is the subject of the formula, and then substitute it into the surface area formula. And then that's going to give us this equation up here that they're asking us to prove. So following on from the volume, so we've said pi r squared multiplied by h equals 500. So therefore, h equals 500 divided by pi r squared. Now we're going to take this one, substitute it in for the h in the surface area formula. Okay, so this will turn out to be 2 pi r multiplied by 500 divided by pi r squared plus 2 pi r. And having a look at this part of the equation, because these are multiplied together, we can cancel some things. So this r will cancel with one of the r's on the bottom line. This 2 times 500, that's 1000. So this will equal 1000. Also the pi's cancel out, so this pi here and this pi on the bottom line cancel out. So on the top line we're left with 1000 divided by r plus 2 pi r squared for the surface area. And that is what they've asked us to show. Okay, part A, that's part A done. Part B says, given that the r can vary, find the dimensions of a can that has minimum surface area. So when you see this word minimum, or if you see maximum, then you should think calculus. Calculus is a really good tool to find the minimum and maximum of different functions. So here we need to find the minimum surface area. So what we need to do is to take the derivative of this surface area formula and then set that equal to 0 to find the radius for the minimum surface area. So for part B, what we want to do is, so for the minimum surface area, we want the derivative of s with respect to r. Okay, so for this we can use the power rule. So take that power, bring it down the front, multiply it by the coefficients here, and subtract 1. So 2 times 2, that'll be 4 pi, and then 2 minus 1 is 1, so we'll have 4 pi r. And again, we can use the power rule, but this is, another way of writing this is 1000 r to the minus 1. So if we bring that minus 1 down the front here, that will be minus 1000 r, and then subtract 1 from the power, so that'll be minus 1000 r to the power of minus 2. Okay, so if we were to write this differently, we might say this is 4 pi r minus 1000 over r squared. Right, so that's the derivative, and we can say the minimum occurs when the derivative equals 0. Okay, so just onto the next page now, we take this formula, 4 pi r minus 1000 divided by r squared, and set that equal to 0, and now we need to solve this for r. So the first thing we could do is to multiply by r squared, multiply everything through by r squared, so therefore we get 4 pi r cubed minus 1000 equal to 0. Then we could say that 4 pi r equals 1000, so add that 1000 to the right hand side, and divide by 4 pi, so r cubed equals 1000 divided by 4 pi, and then take the cube root of that, so r equals the cube root of all of this, and then we can put that into a calculator. I should have simplified that first, just to make it easier on myself. So 1000 divided by 4, that's 250 divided by pi, so we can do the cube root of 250 divided by pi, and we get 4.301, so we can round that off to 4.3. So for the minimum surface area, we have a radius of 4.3 centimeters. And now onto part C. Part C says, with reference to the shape of the can, suggest a reason why the company may choose not to manufacture a can with minimum surface area. Okay, so let's have a look at the height. What would the height be if the radius was 4.3? So we can work that out quickly. So if we substitute 4.3 into this formula, h would equal 500 divided by 5 multiplied by 4.3 squared. So let's put that into a calculator. 500, we get 8.6 about. Okay, so let's think about those dimensions for a little bit. So we've got a height of, so for C, h would equal 8.6 centimeters. The radius is 4.3, so let's have a look at a can. Dimensions of a can. If we were to have the minimum surface area, the height would be 8.6. The diameter would be about 8.6 as well. So we'd have pretty much a square can, or a can as it is wide. And that's a pretty wide can, 8.6 centimeters. If you look at a ruler, get a ruler out and measure 8.6 centimeters, imagine a can being that wide. It is wider than what you would expect a can to be. So why might companies not want to make a can that wide? Well, pretty much because it might not be comfortable for everybody to hold it. Maybe you have really big hands and you'd be fine with holding a can that thick, but some people might not be able to hold that can comfortably. So the people making the soft drink cans, they need to think not just about minimum surface area and saving as much material as possible, but they also need to think about the product they're actually making, and is it comfortable to hold? Can people drink from it? So we can say, try to put that into a sentence. So something like can. So can needs to be held in the hand comfortably. A wide can might be difficult to drink from. Something like that. And that was a 1 mark question. So you just need to, what they're looking for is you to think practically about the question and what the numbers are actually saying to you. Okay, so part A was 3 marks, part B was 5 marks, and part C was 1 mark, for a total of 9 marks for question 14. Question 15 gives us a graph, and it says figure 4 shows a sketch of the curve C with equation y equals 5x to the power 3 on 2 minus 9x plus 11, where x is greater than 0. The point P with coordinates 4, 15 lies on C. The line L is the tangent to C at the point P, the region R, shown shaded in figure 4, is bounded by the curve C, the line L, and the y-axis. Show that the area of R is 24, making your method clear. Then it says solutions based entirely on graphical or numerical methods are not acceptable. So that's pretty much saying you need to use integration to get to your answer for this question. Okay, so let's have a look at this diagram a little bit more closely. We're looking for this shaded region in here, and we've got this line L tangent to the curve at P. And we're told the coordinates of P are 4, 15. Okay, so that shaded region is going to go all the way up to this point P. Even though you can't really see it in there, there's a little bit of shading in there somewhere. And effectively what we're looking for is the area under the curve, subtract the area under that line. So if you were to think of maybe a slightly less complex question, if we didn't have that line L, you might be asked to find this area under the curve here. So from 0 to 4, find the area under the curve C. So what happens when we add that line in? Well, it means we've got all this space that we need to subtract from that area under the curve. So how are we going to firstly find this entire area and then subtract that area under the line? Well, we're going to have to take two integrals. Firstly, the integral of C, then the integral of L, and subtract them. Now, you might be wondering, what do I do about this little triangle down here? Well, it doesn't really matter, because one way to think of it is you can just shift the x-axis down. There's no reason why you can't do that. It doesn't really affect the answer. So what we're actually looking for is this entire area here, subtract the area under the line. Okay, so once we've got the integral of C and the integral of L, we can subtract them, and that will give us R. Okay, I hope that makes sense. So the first thing we need actually is the equation of this line. And we're told that it's a tangent to the curve C. So I can take the derivative of this equation first. That will give me the gradient of the line. Then I can find the equation in order to take the integral of it. Okay, so firstly I need the derivative of C, of the curve C. Okay, so this is going to be, well, we can use the power rule here. So take that power down the front, multiply it by the coefficient. So we've got 3 on 2 multiplied by 5, and then subtract 1 from that power. So 3 on 2 minus 1, that's a half, minus 9, and we get rid of that x after the 9. Okay, then just simplify this a little bit. So this will be 15 on 2 multiplied by the square root of x minus 9. And now we're looking for the gradient of the tangent at the point P. So that'll be where x equals 4. So we can say when x equals 4, the gradient will equal 15 on 2 times 2. So the square root of 4 is 2 minus 9. Here, those 2's will cancel out, and we've just got 15 minus 9, which is 6. So the gradient of L will be 6, so therefore the equation of L will look something like this. Y equals 6x plus c, and we need to find that c to finish this equation off. So then we can say, using 415, because we know that point lies on the line, so we substitute that into this equation. We say that 15 equals 6 multiplied by 4 plus c. So 15 equals 24 plus c. So therefore c equals minus 9. Alright, now what we want to do, well, firstly we can finish this off. We can say that the equation of L is y equals 6x minus 9. Now we can take the integral of that. We'll have to take the integral of the curve C as well. And I might just do those separately, just so it's a bit clearer. So the integral of C was 5x to the power 3 on 2 minus 9x plus 11 dx, and we can use the power rule again for that. So this time we divide by the power, add 1, divide by the power, so this will be 5x to the power 5 on 2 divided by 5 on 2 minus 9x squared divided by 2 plus 11 plus the constant on the end. And then let's just simplify this a little bit. So flip that fraction and multiply. So this will be 5x to the power 5 on 2 multiplied by 2 on 5. And what happens is those 5's cancel out. So for the first term we get 2x to the power 5 on 2 minus 9 on 2 x squared plus 11 plus c. And then we need the integral of the straight line L. So this will be the integral of 6x minus 9 dx equals 6x squared divided by 2. So 6 divided by 2, that would be 3x squared minus 9x plus c. Not too difficult for that one. And then, as I said before, we can take those two integrals and subtract them to find this area R. Okay, so for area R, we're going to take this integral from 0 to 4, 2x to the power 5 on 2, minus 9 on 2, x squared plus 11x, from 0 to 4, subtract 3x squared minus 9x from 0 to 4. And as I said before, you could have done that in one step, but that's personal preference. And then for this one, you can see if I substitute 0 into both of these, they'll just all be 0. So I just really need to worry about substituting the 4 in. So let's go ahead and do that. So substituting 4 into the first part, I'll have 2 times 4 to the power 5 on 2 minus 9 on 2 times 4 squared plus 11 times 4, which is 44. Subtract 3 times 4 squared minus 9 times 4. Okay, and then let's do a bit of mental arithmetic. So 4 to the power 5 on 2, that's like the square root of 4 to the power 5. So the square root of 4 is 2 to the power 5 is 32 times 2, that's 64. 4 squared is 16 divided by 2 is 8 times 9 is 72 plus 44. Subtract 4 squared is 16 times 3, that's 48, minus 9 times 4, that's 36. Okay, so for all of this, 64 minus 72, that's 8 plus 44, that'll be minus 8 plus 44, that's 36. And then subtract 42 minus 36 is 12, so subtract 12, and what do we get? We get 24. And the number we were looking for, area of R is 24, so we've clearly shown through our steps. Perhaps I could have used a bit more explanation in here. I'd suggest perhaps on your exam, if you're sitting this exam, maybe sticking some words in here explaining how this is getting you to area R. Because I'm making a video, obviously I'm explaining it as I go, but if I was sitting the exam, I'd probably try to have a bit of a more written explanation. But I hope that made sense. Just to reiterate the steps, I took the derivative to find a gradient of L, then I found the equation of L, then I took the integrals, then I subtracted the definite integrals from 0 to 4. So a few steps there to get to the final answer, and that was a total of 10 marks for question 15. Question 16 part A says express 1 over p multiplied by 11 minus 2p in partial fractions. So we need to find the two fractions that add together to make this fraction here. So we have 1 over p multiplied by 11 minus 2p. The way we do that, firstly, is we can say this equals, well, the first denominator will be p. The denominator here is already factorized for us, so we don't need to factorize that. We can just say that one denominator will be p, the other one will be 11 minus 2p, and then we're looking for the numerators. So we call those a and b. So what we want to do now is to try to solve this equation. What we're going to do is really we're just multiplying the a by 11 minus 2p and b by this denominator, just like when you add fractions together. So if you had 2 over 3 plus 3 over 5, how would you do that? Well, you would multiply 2 by 5, 3 by 5 to get the common denominator, and 3 by 3 and 5 by 3. So we're just kind of cross multiplying here. So what we end up with is a multiplied by 11 minus 2p plus b multiplied by p equals 1, this numerator up here. Okay, and now we need to try to find a and b. The first thing you can try with partial fractions is to make one of these things equal 0. So either the a part of the equation, so this part, try to make that equal 0, or make this part equal 0. And well, the easiest way I can see right now to make this part equal 0 is to let p equal 0. So if p equals 0, this will be 0 over here. We'll get a multiplied by 11 minus 2 multiplied by 0 is just 0. B multiplied by 0 is just 0. And what we'll get is a multiplied by 11 equals 1. So therefore a equals 1 over 11. Now we want to find b. So how can we get this part to equal 0? Well, 11 minus 2 multiplied by something needs to equal 0. So 2 multiplied by something needs to equal 11. 2 multiplied by what equals 11? This will be 11 on 2. So those 2's will cancel out. We'll just be left with 11. So we need to let p equal 11 on 2 now. So therefore a multiplied by 11 minus 2 times 11 on 2 plus b times 11 on 2 equals 1. Now the whole point of this was to get rid of this part, so 2 times 11 on 2, that's 11. 11 minus 11 is 0, so this bit cancels out, and then we're just left with b multiply 11 on 2 equals 1, so therefore b equals 2 on 11. Alright, so we found our a and our b, our numerators, so therefore we can say that that expression will look like this. So 1 over p multiplied by 11 minus 2p will equal 1 on 11 divided by p plus 2 on 11 divided by 11 minus 2p. You could try to simplify that, but you might as well just leave it as is and don't give yourself any extra work unless it tells you to simplify it as much as possible. It just says express in partial fractions, so you can leave that with the fractions on top if you like. Okay, on to part B. The question goes on, a population of meerkats is being studied. The population is modeled by the differential equation dp over dt equals 1 over 22 multiplied by p multiplied by 11 minus 2p, where t is greater than 0 and p is between 0 and 5.5, where p in thousands is the population of meerkats and t is the time measured in years since the study began. Given that there were 1,000 meerkats in the population when the study began, Part B says determine the time taken in years for this population of meerkats to double. Right, so we're given this differential equation, but we need the time by itself. So these are derivatives clearly, and we need to somehow get to the time. So if we're given derivatives and we want to just get to t from dt, we're going to have to take the antiderivative or the integral to get to t. So somehow we need to integrate this equation so we can get t by itself. Before we do that, if we integrated this, so if we integrated dp on dt, this would be with respect to dt, and then we would end up with p. So that's no use. So we need to rearrange this equation somehow so that we have dt on top of this fraction. So it's, in other words, it'll be the change in time with respect to the population rather than the change in population with respect to time. So we need to flip this around first so that when we do take the antiderivative, we'll be left with time and not the population. Alright, I hope that makes sense. So the first thing I'm going to do, well, I'll write this down here firstly. So I'll start part B down here. We've got the change in population with respect to time equals 1 over 22 multiplied by p multiplied by 11 minus 2p. And as I was saying, I need to flip this around. So one way to think about this is I can multiply this side by dt, divide this side by the numerator over here, but what we're really doing is just flipping the fractions around. So therefore it becomes dt on dp equals 22 on p multiplied by 11 minus 2p. So that was the numerator. This is effectively on the top line. So now it's the denominator. The numerator is now 22. And you'll notice that looks similar to part A, what we started with here. In part A, we had 1 on the top line. Now we have 22 on the top line. We're still trying to get t by itself. So now we need to take the integral or the antiderivative. So dt on dp with respect to p equals the integral of 22 on p multiplied by 11 minus 2p. So when we take this derivative over here, well, firstly, these cancel out, and then we're just left with the antiderivative of the derivative of t. So the antiderivative of derivative, well, that's just going to be t. So on the left, we've got t plus some constant, and then on the right, we have this integral here. Now, the whole point of part A was to split it into partial fractions because that's going to make it easier to integrate. This would be kind of a pain to do, but if we've got it in the form of these partial fractions, it's going to be slightly easier. So this will equal the integral of, now the only difference this 22 makes compared to this 1 here is we need to multiply each of these numerators by 22. So instead of 1 over 11, we'll have 22 times 1 over 11 for the first fraction. So we've got 22 times 1 over 11 all over p plus 22 times 2 over 11 divided by 11 minus 2p. Alright, I'll just simplify that a little bit before I start. So 22 times 1 over 11, well, that's just 2 over p. And 22 times 2 over 11, well, 22 divided by 11 is 2, times 2 is 4. So this simplifies to 4 over 11 minus 2p. Alright, now we need to take the integrals of each of these fractions. You need to remember that the integral of 1 over x is the natural log of x plus some constant. So that's going to help us with this one. Also, if there's some constant on the top, such as 2, that becomes the coefficient. So this would be 2 log x. Another thing that you need to know is if we're taking the integral of some fraction where we have a coefficient of x on the bottom line, what we need to do with the coefficient of the integral is to divide the numerator by that coefficient. So this integral will be 4 divided by 2, so this numerator divided by that coefficient, and then we have the natural log of everything on the bottom line, not just the x, but everything on the bottom line. So the natural log of 2x plus 1 plus some constant. So as long as you can remember those rules, you'll be able to do these ones here. So using those ones there, we can say that therefore the integral of 2 over p is 2 natural log p, and now we have a a coefficient of -2 and the numerator of 4, so the coefficient here will be 4 divided by -2, which is -2, natural log of 11 minus 2p. And we've already got this constant on the left hand side. We don't really need to add another one on this side. I mean, they just combine to make some unknown constant, so you don't need two of them. And now we have our equation. We're almost finished. We still need to find this constant here, and we need to go back to the question now because it gives us a little bit of information to help us find that constant. So it says, given that there were 1,000 meerkats in the population, so 1,000 meerkats, that was p in thousands, so therefore p equals 1. And it says when the study began, so that's when t equals 0. So we know that when t equals 0, p equals 1. So we can substitute those values into this equation to find that constant. So when p equals 1, t equals 0. So let's go ahead and substitute those in. So therefore, 0 plus c equals 2 log of 1 minus 2 log of 11 minus 2. Okay, so we've got c equal to, well, log of 1 is just 0, so that cancels out. And then we've got minus 2 log of 9 for the constant there. So therefore, if we were to plug that in there, we would get t minus 2 log 9 equals 2 log p minus 2 log 11 minus 2p. All right, lots of logs in there. And remember, we still actually haven't answered the question. We've done all the work ready to answer the question, but the question did say, determine the time taken in years for this population of meerkats to double. So what would happen if the population doubled? Well, that would be p equal to 2. So 2,000 meerkats, p would equal 2. So we need to find when p equals 2. All right, so we can substitute that into this equation. T would equal, now I'm going to add that constant to the right hand side. So we get 2 log 2 minus 2 log 11 minus 4, 2 times 2 is 4, plus 2 log 9. All right, so we could just put that into a calculator. So 2 log 2 minus 2 log 7 plus 2 log 9, and we get 1.8889. So therefore t equals 1.89 years, and we can say 2 dp. Alright, so that's part B. Part C says show that p equals a over b plus c multiplied by e to the minus half t, where a, b, and c are integers to be found. So for part B, we rearrange the formula to make t the subject of the equation. Now we need to rearrange it to make p the subject of the equation. Alright, so we have our equation here. I'll just rewrite that down here. So C, we've got t equal to 2 log p minus 2 log 11 minus 2p plus 2 log 9. Okay, so for this we're going to need our log laws first. So you remember that if we have the log of a minus the log of b, that can be written as the log of a divided by b. Also, we know that if we have the log of a plus the log of b, we'll get the log of a times b. We can use those ideas here to simplify this right hand side a little bit. So therefore t will equal, actually firstly I'll factorize a 2 out of each term just to make it a little bit easier. So this will be log p minus log 11 minus 2p plus log of 9. And then we can write this as a fraction and then multiply by 9. So we've got the log of 9p divided by 11 minus 2p. So hopefully you can see I've divided p by this part here, p divided by 11 minus 2p, and then multiplied that by 9. So 9p over 11 minus 2p. And then remember, I need to get p by itself somehow. First thing I'm going to do is divide by 2 on the left hand side. So I'll get t divided by 2 equals the natural log of 9p on 11 minus 2p. Now, how do I get rid of a natural log? Well, I need to raise it to the power of e. If you have, say, the log of base 10 of 10, well, that equals 1. Well, what happens if you raise both of those sides as a power? So you get 10 log 10 of 10 equal to 10 to the 1. What that does is it just basically gets rid of all of this. So you're just left with this power here. So if you think about that logically, well, if you're raising the base, if you're raising the log to the base, you're kind of just undoing what you've just done by doing the log operation. So the natural log is log base e. So if you raise that to the power of e, you will just be left with what's inside the log. All right, so we have to raise both sides as powers of e. So on the left we'll get e to the power of t on 2, and on the right we'll have e to the power of natural log 9p divided by 11 minus 2p. And as I said, that means we can get rid of all of this. So on the right we've just got e to the power of t on 2 equal to 9p divided by 11 minus 2p. Alright, now we just need to do some algebra so that we can get p by itself somehow. So the first thing I would do is multiply the left hand side by this denominator here. So we get 11 minus 2p multiplied by e to the power of t on 2 equal to 9p. Then I would perhaps divide the other side by e to the power of t on 2. That might sound a little bit counterproductive, but bear with me, you will see where I'm going. So on the left, I'm left with 11 minus 2p equal to 9p. Now, rather than writing this as a fraction, I'll write that power as a negative, so minus t on 2. So this is the same as if I have 1 on 2, I can write that as 2 to the minus 1. So I just added a negative to that power rather than writing that as a fraction. Then I'm going to get rid of this p on the right hand side. So I want to isolate all of the p's on the left hand side. So divide by p on the left. So I get 11 minus 2p divided by p equal to 9e to the minus t on 2. Split this into two fractions, so it's 11 over p minus 2p on p. Now what happens with those p's? Well, they can just cancel out. So this is equal to 9e to the minus t on 2. Add that 2 to the other side. Now I've just got that minus 2 by itself. So on the left, all I'm left with is 11 over p equal to 9e to the minus t on 2 plus 2. Then swap these over. So this p multiplied over the right hand side, divide by all of this on the left hand side. So once we flip those around, we'll be left with p equal to 11 divided by 2 plus 9e to the minus t on 2. All right, now let's go back to the question again. They wanted it in the form a over b plus c multiplied by e to the minus half t. So minus t on 2 is the same as minus a half t. And that looks good. So therefore a in my final solution, a equals 11, b equals 2, and c equals 9. That was question 16 for 12 marks. Let's just have a look at the breakdown of the marks again. So part A was 3 marks, part B was 6 marks, and part C was 3 marks. And that is the end of this paper for a total of 100 marks. I hope you found this video useful. I know that sometimes I rush through some questions in these videos. I'm not trying to kind of give an in-depth explanation of each topic. I am kind of trying to keep it a bit shorter because it is an exam walkthrough. It's not kind of trying to teach each topic by itself. So I hope I gave enough explanation to each question. If you found that useful, let me know, leave a like. If you want to see more content, subscribe. Good luck with the rest of your revision, and I'll see you in the next one. Bye for now.